So absorption of proteins in the small intestine. So um, first they make proteins undergo mechanical digestion in the oral cavity, but they don't undergo chemical digestion until they reach the stomach. And in the stomach, there's zymogens that break down the proteins. So first is trypsin. Trypsin is released by um, the chief cells in the stomach. Um, chief cells actually release trypsinogen, but the parietal cells release hydrochloric acid, and that hydrochloric acid increases the acidity of the stomach to around 2, which then cleaves the trypsinogen into its active form, trypsin. So trypsin is the first one. Next is chymotrypsin, and chymotrypsin is activated by a enterokinase chymotrypsinogen is cleaved by enterokinase to become chymotrypsin. Chymotrypsin can cleave the aromatic amino acids. And finally, there's carboxypeptidase, which will cleave peptides at their carboxyl end. So now there are small peptides, and these small peptides will be broken down into tripeptides, dipeptides, and singular amino acids at the brush border of the enterocytes. Now, at the apical side, you'll have it similar to how the disaccharides are digested by the enterocytes. You'll have the brush border enzymes, but this time they're peptidases instead of disaccharidases that break down the peptides, the tri, bi, and singular amino acids. However, and also on the basolateral side, you'll have the same sodium-potassium pump that's maintaining the sodium electrochemical gradient. However, a difference between digestion of carbohydrates and proteins is that on the apical side of the enterocyte, there's also a sodium-hydrogen exchanger. And what this does is this creates a second electrochemical gradient, and this time it's a hydrogen ion electrochemical gradient. So what this enables is that you're going to have co-transport of the singular amino acids using the sodium electrochemical gradient, and then you're going to have also co-transport of the tri and bipeptides using the hydrogen ion electrochemical gradient. So now that the tri, bi, and singular amino acids have reached into the inside of the enterocyte, what happens is the tri and bipeptides are broken down into singular amino acids, and these amino acids will leave and through the basolateral side of the enterocyte, go into the bloodstream, and go into the cells that need it.